Today we are on page 3 of our Chapter 3 notes packet. Section 3.3, Simplifying Radicals. Here are the steps we are going to follow. To simplify a radical, express the radicand as the product of factors. The largest perfect square or cube or nth factor, followed by the non-perfect square or cube or nth factors. Find the root of the perfect factors from A. This is the coefficient of the radical answer. The B part is the radicand of the radical answer. Okay, so we are going to express as the product of factors, the largest perfect factor, and then the non-perfect factors. So it's helpful to keep in mind and know your perfect squares. Right? Your perfect squares are 4, 9, 16, 25, 36, 49, and so on. Why? Because the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5, and so on. Perfect cubes are 8, right? 2 cubed is 8, so the cube root of 8 would be 2. 27 is a perfect cube, its cube root is 3. 64, its cube root is 4. 125, the cube root of 125 is 5. 216, cube root is 6. 343 would be the cube root, its cube root is 7. 512 has a cube root of 8. 729, a cube root of 9. And 1000, cube root of 10. Other powers to know, 2 to the 4th. 2 times 2 times 2 times 2 is 16. 3 to the 4th. 3 times 3 times 3 times 3 is 81. 2 to the 5th. Well, that's one more than 2 to the 4th. So if I take 2 to the 4th, 16, and times it by 2, 2 to the 5th is 32. And 2 to the 6th is 64. So we're asked to simplify the square root of 50. We are going to express 50 as a product of factors. The largest perfect square factor of 50 is 25. So we express 50 as 25 times 2. I'm going to say to circle that largest perfect factor. Take its square root. The square root of 25 is 5. So 5 comes out of the radical, and the square root of 2 remains. So the square root of 50 simplifies to 5 square root of 2. Number 2, the square root of 700. The largest perfect square factor of 700 is 100. 700 can be written as 100 times 7. 100 is the perfect factor, circle it, take out its square root, the square root of 100 is 10, and what's left remains, square root of 7. So 10 square root of 7. Number 3, the square root of 72, xy to the 4th. 72. It's 36 times 2. X is not perfect. Y to the 4th is, circle our perfect factors, right? 36 and y to the 4th are perfect squares. Take their square roots. 6, the square root of y to the 4th is y to the 2nd, right? Divide it by 2. And then the square root of 2x remains as the radical. So 6y squared, square root of 2x. Number 4, the square root of 32, x to the 5th. We'll factor 32 into 16 times 2. And x to the 5th, what part of x to the 5th is perfect square? Would be x to the 4th, so we'll express x to the 5th as x to the fourth times x. So we've simply broken down 32x to the fifth as factors of 16 times 2 times x to the fourth times x. Circle our perfect squares. Take their square roots, 4x squared, and then the square root of 2x remains. Number 5 is cube root. We want the cube root of negative 512x to the fifth. Cube root of, so we're breaking negative 512 is a perfect cube. X to the fifth is not. What part of it is, though? X to the third. So we'll break x to the fifth down into x to the third times x squared. Circle our perfect cubes. Take their cube root. Cube root of negative 512 is negative 8. And the cube root of x to the third is x. And x squared remains under our radical. So negative 8x cube root of x squared. Number 6, they're asking for the fourth root of this fraction. Let's break the numerator down into factors. 16 is perfect. What part of x to the fifth can we take the fourth root of? X to the fourth. So we'll break x to the fifth down into x to the fourth times x. 81 is perfect. And y to the 16th also has a fourth root. Circle our perfect factors. The fourth root of 16 is 2. The fourth root of x to the fourth is x. The fourth root of x remains. And the fourth root of 81 is 3. The fourth root of y to the 16th, again, you're dividing 16 by 4, and that's 4. So this is 2x, fourth root of x, over 3y to the fourth. It's important to note a simplified radical cannot have a fraction radicand. Also, a denominator may not contain a radical. If a radicand is a fraction, we multiply the numerator and denominator by a value which will make the denominator a perfect square, cube, or nth power. Then take the root. To simplify, the square root of 2/3. This cannot be simplified as it is, but we cannot leave a radical in a denominator. So we're going to multiply by 1 in the form of 3/3, and that'll get us 2 times 3 is 6, and 3 times 3 is 9. So now we can take the square root of at least the denominator and leave the radical in the numerator. That's okay. Right? So the square root of 9 is 3. So this is equal to the square root of 6/3. To simplify, the square root of 5x over 6y. Again, the focus is on the denominator. We have to bring this up to something that we can take the square root of. So if we multiply it by itself, 6y, then we'll end up with 36y squared for the denominator, which we can take the square root of and simplify. Well, if we multiply the denominator by 6y, we need to do the same to the numerator. So multiply the numerator by 6y, you get 30xy over 36y squared. And now the 36y squared, its square root is 6y. So our answer here is square root of 30xy over 6y. Again, we cannot leave any fraction with a radical in its denominator. Radical in the numerator is okay, but not in the denominator. Our next example, the square root of 7x to the 5th over 5y to the 7th. Okay, if I focus on the denominator here, if I multiply by 5, that'll bring us up to 25. And the y to the 7th, if we simply multiply by y, that will bring us up to y to the 8th, which is a perfect square factor. So we multiply by 5y over 5y, both numerator and denominator, and we end up with 35x to the 5th y over 25y to the 8th. Now, this should have been broken down into x to the 4th times x, okay, and x to the 4th, its square root is x squared. Our denominator is a perfect square. Take a square root, that's 5y to the 4th. Now, let's try these two together. Or excuse me, 3 of them together. Number 7, okay. Focus on the denominator. This part is a perfect square, that's good, but a to the 3rd is not. So we want to multiply by a to bring it up to a to the 4th. So multiply the numerator by a as well. So we have the square root of 10a over 9a to the 4th. Denominator can be simplified. Both are perfect square factors. So this is equal to the square root of 10a over 3a squared. Next, number 8, we have 3 times the square root of 5a to the 7th over 9b to the 7th. Again, our focus is always going to be on the denominator. This denominator always has to be a rational number. It cannot remain a radical. So if we bring b to the 7th up to b to the 8th, to multiply by b, we'll just copy down the 3 for now. That's a 3 times this radical. It's not a cube root. It's not a root. And I'm going to, when I multiply here, I'm going to break this up. This is going to be 5 a to the 6th times a times b over 9b to the 8th. I'll circle my perfect square factors. Copy down the 3. The square root of a to the 6th is a to the 3rd. Square root of 5ab remain. And in the denominator, both are perfect squares. Out come their square roots. That would be 3b to the 4th. And we're not done quite yet. These 3's can divide out. So our answer is a to the 3rd, square root of 5ab over b to the 4th. And number 9, again, focus on the denominator. Now this is asking for a cube root, all right? The denominator is y to the 5th. It has to be a multiple of 3 to be a perfect cube. The exponent does. The exponent needs to be a multiple of 3 to be a perfect cube. Okay, so now let's multiply by y to bring this up to y to the 6th. So this is a cube root of, what part of 16 is a perfect cube? 8. So I'll factor 16 and 8 times 2. X to the 3rd times x times y over y to the 6th. I'll circle our perfect cubes. Cube root of 8 is 2. Cube root of x to the 3rd is x. Cube root of 2xy remains, all over the cube root of y to the 6th, which is y to the 3rd. That's our answer here. Now I'm going to ask you to try 1. All right. So if you can add a number 10 down here after number 7. And if you would try on your own the square root of 7x squared over 2y to the third. All right. Try that on your own. And we'll go over that tomorrow. And this completes our notes for today.